Hello and welcome back at the Finet channel where we are with wireless LAN configuration part 2, where the purpose of the material is to implement a wireless LAN using a wireless router that was done in the first video and a wireless controller. At the first material, at the first video, we configured the wireless LAN to support a remote site. We configured a wireless controller for the wireless LAN to use the management interface of Wi-Fi protected access to with phase shift key authentication. And now we will configure wireless LAN controller for wireless LAN to use a VLAN interface, a DHCP server, and a Wi-Fi protected access to enterprise authentication. After we are done with this, we will troubleshoot common wireless configuration issues. Here in the figure that is shown to the slide, we have a PCA that is running a simple network management protocol, SNMP, and remote authentication dial-in user service radio server software. A simple network management protocol is used to monitor the network. The network administrator wants the wireless controller to forward all the simple network management protocol log messages called traps to the simple network management protocol server. In addition, for wireless LAN user authentication, the network administrator wants to use a radio server for authentication, authorization, and accounting services. Instead of entering a publicly known pre-shared key to authenticate, as they do with Wi-Fi protected access to phase shift key, users will enter their own username and password credential. The credential will be verified to added or modified from a central location, where the radio service is required for wireless LAN that are using Wi-Fi protected access to enterprise authentication. So what we will do is that we have to configure the server information for our network. So the first thing we need to do is to configure the simple network management protocol server. So to do this, we have to click at the Management tab to access a variety of management features. The simple network management protocol is listed at the top of the menu on the left. If we click there, we can expand the submenus and then we click Trap Receivers. After we click the trap receivers, we have to click New to configure a new simple network management protocol. And all of these steps are shown here in this figure. After we enter the simple network management protocol community name and the IP address IPv4 or IPv6 for the server, we click Apply. The wireless controller will now forward these log messages about Simple Network Management Protocol to the Simple Network Manager Protocol server. After we are done with Simple Network Manager Protocol, let's configure a radio server. So in our example configuration, the network administrator wants to configure a wireless LAN using the Wi-Fi protected access to enterprise as opposed to Wi-Fi protected access to personal or Wi-Fi protected access to phase shift key. Authentication will be handled by the radio server, which is running on the PCA. To configure the wireless controller with the radio server information, we have to click at the Security tab. Then we go to the radius. So you have to follow step 1, 2, 3 through the radius. Then we go to Authentication. And as you can see, for the moment, there is no server radius currently configured. By clicking New, we have to add the PCA as a radius server. So what we will need to do, we have to enter the IPv4 address for the PCA and the shared secret. This is the password between the wireless controller and the radio server. It is not for users. We click Apply, as it is shown here in this figure. After clicking the Apply, the list of configured radius authentication server refreshes with the new server listed as it is shown here in this figure. Now we are done with configuring both information about the servers, Simple Network Management Protocol and the radius server. So now let's go and configure the VLANs. Each wireless LAN configured on the wireless controller needs its own virtual interface. The wireless controller has 5 physical ports for the data traffic. Each physical port can be configured to multiple wireless LAN and each on its own virtual interface. Physical ports can also be aggregated to create high bandwidth links. The network administrator has to decide that the new wireless LAN will use interface VLAN 5, for example, and the network 192.168.5.0/24. Router 1 already has a sub-interface configured and inactive for VLAN 5 as it is shown here in this topology if we use the show IP interface brief. And we can check the output from this command. So now what we need to do is to configure a new interface. Because a VLAN interface configuration on the wireless controller includes 6 steps. And the first step is creating a new interface. To add a new interface, we click on the controller and then we go to the interfaces and then we click at new. After we create the new interface, we have to configure the VLAN name and the ID. So, as you can see, we are entering the interface name as VLAN 5 and the VLAN ID as number 5. And then we have to click Apply. After that, the third step is configuring the port and the interface addresses. On the Edit page that it opened for the interface, you have to configure the physical port, which in this case is Giga Ethernet 1 in the topology and is port number 1 on the wireless controller. Then we configure the VLAN 5 interface addressing, as it is shown here in the figure, with which is an IP assigned per IPv4 address 192.168.5.254/24, and the default gateway is the router 1 IP address as 192.168.5.1. And after we are done with this, we have to configure the DHCP server address. So we go down at the other part where it is the DHCP information, because in the larger enterprise, wireless controller will be configured to forward DHCP messages to a dictated DHCP server. That's why we have to scroll down to the DHCP information, where we need to configure the primary DHCP server as IPv4 address 192.168.5.1. This and you can understand that this is the default gateway router address. The router is configured with a DHCP pool for the wireless LAN network, and as host join the wireless LAN that is associated with the VLAN 5 interface, they will receive addressing information from this pool. And the fifth step is to apply all the information that we just configured. So we tap apply, and then at the window that is a warning message, we click OK. And after that, which means that we created our new interface, and the sixth step is verifying the interface that we just created. By clicking at the interfaces, we see that now the new VLAN 5 with the number 5 as a VLAN identifier, it is shown in the list of interfaces with the IP address as 192.168.5.254. And so we created our interface. The next step is configure a DHCP scope. So here again, it includes some steps to configure the DHCP scope. So the steps will be 5 when we create a new DHCP scope at the first step, because it is very similar to a DHCP pool on a router. It can be include a variety of information, including a pool of addresses to assign to a DHCP client, DNS server information, list time, and more. To configure this new DHCP scope, we click at the internal DHCP server, and then we select the DHCP scope. And the window that it is shown, we click at New. After we click at New, we will have a new window, as it is shown here, where we will add the name of our DHCP, because the scope will apply to the wireless management network. And that's why the network administrator used the wireless management as the name of the DHCP. And then we click apply. Now that we created our DHCP scope, what we need to do is to verify that the new DHCP scope is configured. For this, you have to return to the DHCP scopes page, and then we can verify that the scope is already configured and it is listed at the DHCP scopes. So what we do, we click this new scope that we created, and then we start configuring. So after we click that, we have a window when we can edit the information about this scope. And when here we will configure a pool of addresses for the 192.168.200.0/24, which means that by selecting the start IP address and the end IP address, you can see here that the network starting at .240 to 249. The network addresses and subnet mask are configured too. The default router IPv4 address is configured, which is the sub-interface of the router 1, and as you can see here is 192.168.200.1. All this information is from the topology that we had a couple of slides before. So here we left all other information of the scope unchanged. The network administrator then what need to do is to select enabled from the status drop here, and then needs to click apply. So after we configured the DHCP scope now, so we edited the information and all the, we need to check the verification, the configuration that we just did. So once again, what we do, as a network administrator, we return to a DHCP scope page, and then we verify that our wireless management scope, which is the name of the DHCP scope that we just created, now it is configured, and this is the address pool, and it shows the lease time and the status that is enabled. The next thing that we need to do is configure a Wi-Fi Protect access to enterprise wireless LAN, because by default, all new created wireless LAN on the wireless controller will use a Wi-Fi Protect access to an advanced encryption system. The default key management protocol used to communicate with the radio server is 802.1x. Because the network administrator already configured the wireless controller with the IPv4 address of the radio server running on the PCA, the only configuration left to do is to create a new wireless LAN to use this interface VLAN 5. So let's create a new wireless LAN. So what we need to do is we go to the VLAN tab, and then we click Go to create a new VLAN. So we have to fill the profile name and the SSID in order to be consistent with the VLAN that was previously configured. We choose the ID 5, and then we click Apply. The wireless LAN now it is created, and then we have to enable this wireless LAN for the VLAN 5 that we created before. And since wireless LAN is created, but it still needs to be enabled and associated with the correct VLAN interface, change the status to enabled and choose VLAN 5 for the interface group listed down there. So we first do the status enabled. We select the interface VLAN 5, and then we click apply. We will have a warning message. Then we have to accept as it is shown here in this figure. And after that, we will verify the advanced encryption system and the 802.1x default. By clicking at the Security tab, we can view the default security configuration for the new wireless LAN. The wireless LAN will use the Wi-Fi protected access to security with advanced encryption system. Authentication traffic is handled for the 802.1x between the wireless controller and the radio server. So after this, what we will do, we will configure the radio server. So now we need to select the radius. So we go to the AA server, and we need to select the radio server that will be used to authenticate user for this wireless LAN. By clicking this AA servers tab in the drop box that will be shown, we select the box radius. Server that was configured on the wireless controller. So we select it and we choose the server, which we choose by the IP address, and then we apply our changes. And the last step is to verify that the new wireless LAN is enabled. To verify this, we go back or we go to submenu wireless LAN, and we see that both wireless LAN and the company name, it is listed. Both of those are enabled, and both of those are using Wi-Fi Protect Access 2 with phase shift key authentication. Company name you can see that it is using even the 802.1x1 authentication. So these are all the steps what we need to do for configuring a Wi-Fi protected access to enterprise wireless LAN on the wireless controller. And now that we are done even with this configuring, let's go and do some troubleshooting. When we do troubleshooting, there may be different kind of problems where those network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. You as a technician and as an administrator must be able to analyze the problem and determine the cause of the error because it is important and before they can resolve the network issues. This process is called troubleshooting. Troubleshooting any sort of network problem should follow a systemic approach, a common and efficient troubleshooting methodology that is based on the scientific method and can be broken into the 6 main steps as it is shown here in this slide, where the first step is by identifying the problem. Then you have to establish a theory of probable cause. We need to test the theory to determine the cause, and after that we have to establish a plan of action to resolve the problem and implement the solution. We verify the full system functionality and implement preventive measures. And the last step is for every document findings, action, and outcomes. For everything that we have done, we have to document it. To access the problems, determine how many devices on the network are experiencing the problem. If there is a problem that one device on the network, start troubleshooting process at the device. If there is a problem that with all devices on the network, start troubleshooting process at the device where all the devices are connected. You should develop a logical and consistent method for diagnosing network problems by eliminating one problem at a time. So when we troubleshoot a wireless LAN, a process of eliminating is recommended. Here we have a figure where a wireless client is not connecting to the wireless LAN. So we need to know if there is no connectivity at all or if the PC is operation but the wireless connection is performing poorly. So at the first issue when probably there is no connectivity, we have some steps. First, we confirm that the network configuration of the PC using the ipconfig command. And here we can verify that the PC has received an IP address via DHCP server or is configured with a static IP address. The next step, we confirm that the device can connect to the wired network. So we connect the device to the wired wireless LAN and ping a known IP address. If necessary, we reload drivers as appropriate for the client. It may be necessary to try a different wireless network interface card. If the wireless interface card of the client is working, check the security mode and the encryption setting on the client. If the security settings do not match, the client cannot gain access to the wireless LAN. And if the PC is operational but the wireless connection is performing poorly, we have to go some other steps. First is how far is the PC from an access point? Is the PC out of the plane coverage area? Or we can check the channel setting on the wireless client because the client software should detect the appropriate channel as long as the SSID is correct. Then we have to check for the presence of other devices in the area that might be interfering with the 2.4 gigahertz band. Examples of our devices are cordless phone, baby monitors, microwave ovens, wireless security system, and potentially rogue access point. Data from these devices can cause interference in the wireless LAN and intermittent connection problems between a wireless client and access point. Next, you have to ensure that all the devices are actually in place. You consider a possible physical security issues because is there power to all devices and are they all powered on? Finally, inspect links between cable devices looking for bad connectors or damaged or missing cables. If the physical plant is in place, verify the wired LAN by pinging devices including the access point. If connectivity still fails at the point, perhaps something is wrong with the access point or its configuration. When the user PC is eliminated as the source of the problem and the physical status of the device is confirmed, begin investigating the performance of the access point. Check the power status of the access point. So let's see how we can troubleshoot a network when it is running slow. To optimize and increase the bandwidth of the 802.11 dual band routers and access point, we can upgrade the wireless client. So the older devices as 802.11b, G, and 11n can slow the entire wireless LAN. For the best performance, all wireless devices should support the same highest acceptable standard. That's why we have to upgrade our wireless devices. The other thing is by splitting the traffic. The easiest way to improve wireless performance is to split the wireless traffic between the 802.11 and 2.4 GHz band and the 5 GHz and therefore the 802.11 and or better can use the two band as to separate wireless network to help manage the traffic. For example, use the 2.4 GHz network for basic internet tasks such as web browsing, email, download, and use the 5 GHz band for streaming multimedia as it can be shown here in this figure. Because there are several reasons that we use a split traffic approach. The 2.4 GHz band may be suitable for basic internet traffic that is not time sensitive. The bandwidth may be still shared with other nearby wireless LAN. The 5 GHz band is much less crowded than the 2.4 GHz, ideal for streaming multimedia. The 5 GHz band has more channels, therefore the channel chosen is likely interference-free. By default, dual band routers and IPs use the same network name on both the 2.4 GHz band and 5 GHz band. The simplest way to segment traffic is to rename one of the wireless network with a separate descriptive name, and it is easier to connect with the right network. To improve the range of a wireless network, you have to ensure that the wireless router of access point location is free of obstructions such as furniture, fixture, and tall appliance. This blocks the signal, which shortens the range of wireless LAN. If this still does not solve the problem, when a Wi-Fi range extender or deploying the power line wireless can be used. Most wireless router and access point offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers as well as security vulnerabilities. You should periodically check the router or access point for updated firmware. In the figure, here we have the network administrator, which is verifying that the firmware is up to date on a Cisco Meraki access point. On the wireless controller, there will most likely be the ability to upgrade the firmware on all access points that the wireless controller controls. Here, the network administrator is downloading the firmware image that will be used to upgrade all the access points. On a Cisco 3504 wireless controller, We click at the wireless tab, then we go to the access points from the left menu, global. We go to the global configuration. Then we scroll to the bottom of the page for the access point image pre-downloaded section. Users will be disconnected from the wireless LAN and the internet until the upgrade finishes. The wireless router may need to reboot several times before normal network operations are restored. And with this, we are ending all the information about the configuration in the wireless LAN. If you like the video, share it with your friends, and if you are new, do not forget to subscribe to this channel. See you in the next session.